Hello everyone, welcome to Pepcoding. Today we are here to solve question name remove at in doubly linked list. Okay, so in this question what we are going to do, we will discuss it. Okay, first of all let's have a look on the code that we have. We are given with a partially written doubly linked list. Okay, and we have some function like here we have some exception function, list is empty and index is invalid. After that we have some basic functions, add functions like add first node, add first, add last node, add last, add node, add. Okay, and add. You remember we have done this question add in the previous video. Okay, then we have some remove functions, and here we have this function remove add that we have to complete. Okay, so what we have to do, we have to complete this function remove add. This question what it will do, it will simply remove the node that is present at the given index. Okay, and then we have some get functions here. Okay, so now let's go on the board first and discuss how we are going to approach this question. Okay, after that we will look for the solution here. So we are here, just suppose this is the given linked list that we have. Okay, so if someone says that you have to remove the node of fourth index, it means we have to remove this. So what will happen, this node will be removed, this node will be directly connected to this node. Just let me show you how we are going to do this. Okay, this will be removed and this will be directly connected to this. Okay, if it happens, what will happen, index will directly going to change. It will be 4, it will be 5, it will be 6. Okay, so we have to do this. This is our task. So we have now this. Okay, and now let's start discussing about how we are going to solve this. Okay, just suppose first of all we need to take care of the exceptions. So if just suppose the given links list is empty, it means it doesn't have any node. And if I say you have to remove the node of at any given index, so is it possible that if your linked list is empty you can remove the node from any index? No, right? So we have to handle this exception, like if there is no node present, so we have to handle that. Let's go and start writing the code for this. Okay, so first of all we have seen that there were exception. Here we are going to use these two functions of exception. One is list is empty, that will handle that if list is empty we have to return nothing -1. Okay, and then we will handle this second function, index is invalid exception. It means what it means, we will discuss it later. First of all let's write for this. So let's copy this also. Okay, let's go. Okay, remove. Yeah, we are here. So if this returns us true, what it means, it means the list is empty. So what we will do, we'll simply return -1. Okay, after this what we are going to do, we are going to see if it is the valid index or not. Like if it is not, like if this is not null, so the index that is given to us, is it valid, like is it in the range? So how we are going to do that, we have done it previously in the previous question, so let's move forward and do this. So else if there are a function upside also for this also, here index is invalid exception, so we'll copy this, and inside this we have to pass the index, left range and the right range. Okay, so let's go where we were writing the function here. So if index is invalid exception, inside this we have to pass some values. First of all that was index, so it is index, and the second thing was starting index. So what will be the starting index, like what will be the starting range, just suppose. Okay, so just suppose this is the given linked list, so we can clearly see that the range will be starting from 0. Okay, so it starts from 0 and it will go from 0 to length -1. Like just suppose the length is 1 2 3 4 5 6 7 and 8. Okay, but the index is 7, so we can remove up to 7th index. Okay, so it will be length -1, the right range will be length -1. So let's go, we will write here the starting index will be 0, the starting range will be 0, and the right range, the last range will be this dot size -1. Okay, if it is true, what we will do, we will return -1. Okay, this is also done. Now what is happening? Now let's see what is happening. Okay, so it else means that we are having the correct index, like either not the list is empty, nor the index is invalid. It means we just have to now focus on removing the node. Now let's go here. So we will return something from here. So it is integer type, we have to return the data. Okay, so first of all, what we have remove node at. What we will do, we will send the index. Okay, and we have to return the data, so for that we are returning the data from here. Okay, so this is done. Now we are going to make a new function, remove node add. So for that we are going to use private, of course, private, and then we have to node, and then the name of the function is remove node add. So remove node add. Okay, oh, what happened? Okay, we are here. Remove node add. Inside this, what we are having an index, so int index. Okay, what we are going to do inside this function, first of all, let's go on the board and discuss there. After that we will see what we are going to do. Okay, so here, just suppose if the given index is 0. Okay, so what it means remove the first node. Like, do you remember something? We have done the question, remove first node from the doubly linked. Okay, so this is same as if the index is equals to 0, it means we have to remove the first node. Okay, so as we know, we all have studied, so we have to use the function that is called remove first node. Let's go and see. Yes, is it here? Yeah, remove first node. This is the function that we have written in the previous question. So if you haven't seen that video, if you haven't done that question, I recommend you to go do that question by yourself. If you get stuck, please watch the video. Okay, so let's move forward now. We are here. We have to first of all check if the given index is equals to 0. So if the given index is equals to 0, what it means? It means we have to call the remove first function. Okay, so we will simply call remove first node, and the work is done. Okay, so let's move towards the else part. Just suppose, let's go on the board. If the index is equals to the length minus 1 of this linked list, what it means? It means we have to remove the last node. Okay, so you remember something? We have done this question also, remove the last node from the linked list. So is it very simple not for you? Let's go and see. We have this also, remove last node. This is the function that we are going to call. So where we were here. Else if the index is equals to this dot size minus 1. So what we are going to do? We are going to call remove last node. Okay, this is also done. Now we are about to enter in else. What in else? Just think once. Let's go on the board again. Here what we are doing, simply we have handled this zeroth index. We have handled for the last 7th index. So what range we are left with? The list is not empty. We have checked that also. The index is not invalid. Not invalid means it is neither less than 0 or nor greater than the length minus 1. Okay, so it means what we are left with? We are left with this range only this range. If we are under else, it means we are just in this range. Okay, so now what we have to do? Suppose we have to remove a this third index. Let me make some space first. Okay, this is clear now. Yes, just suppose we have to remove this third index. What we need to do? First of all, we need this index. Whatever is present at this index, we need this to remove this. Okay, so let's go and write for it. Okay, so we are here in else. Inside this, what we are going to do, we are going to define a node. You can call it current. It equals to get node add. We are going to use the function get node add here. Okay, let me show you. We have used this function in the previous question also, get node add. What it will do, it will return us this node that we want to delete. Okay, let's go. So node current equals to get node add. Inside this we'll pass our index. Okay, so in the current, what we have the index value. Okay, the index, the node that is present at that index. Okay, so now what we are going to do, we are going to get the previous and the forward node. Like, just suppose this was the current node that we have. Now we are going to get this previous and this next, you can say forward node. Okay, so let's go and make it here. So node previous is equals to current dot previous, and we have to find the next node also. So node forward equals to current dot next. This is also done. Now what? Just suppose we have this point also and this point also. So now we just have to break this two links and we have to connect these two nodes. So this node will be deleted automatically. Now let's go and see. For that, what we have to do, in the next of previous, what we need the forward value. So previous dot next is equals to forward. Okay, this is done. And after that, what we need the previous of forward needs to be where it is. Yeah, the previous of forward needs to be the previous one. Okay, so forward dot previous is equals to previous. This is done. Now what? Let's have a look now. So let's go on the board and see what this code is doing. So what we have done, just suppose we have to remove this. So first of all, we have put the next of previous to the forward. So this link is removed. So let's go and remove this. Okay, this is gone. And we have said the previous of forward is previous. So this link is also gone and a new link is formed. What that is? That is this. Okay, so this is done. Now after this, what we need to do, we need to do what? We need to make the next of current is null and the previous of current is null. Now let's go and do that also. So current dot next is equals to null and current dot previous equals to null. Oh, by mistake. Done. After this, what do you need to do? Just suppose this list is removed now. This node is removed now. Okay, so let me break the connection here also, here also. So now do you really think that this is the third index? Not really, actually. Okay, this is not the third now. Now the third is this, fourth is this, fifth is this, and sixth is this. You can see that the size of this linked list is decreased by 1. So don't forget to do that also. So this dot size minus minus. Okay, so this part is done. Now let's take this code and write on this code for some examples. Okay, the code is here now. Okay, Let's undo the changes that we have done. Okay. Yes, this was connected to this was connected to this was connected to this was connected to this. Okay, so this was the linked list. Okay, the index is 3. Let me erase this also. Okay, done. 4, 5, 6 and 7. So this was the index. Now suppose we have to remove the index, remove the node at index 1. So what will happen? This won't this statement won't execute, this statement won't execute, will come in this part. What will happen? First of all, we'll get the current node, so this will become current. After that, we'll get the previous one, this is previous, and this, we will get the next one, that is forward. Okay, after that, what we are doing, previous dot next is equal to forward, so previous dot next is equals to forward. This link is built, this link is removed, so this link is gone. After that, forward dot previous is previous, so forward dot previous is equal to previous. We are here, and this link is gone. Now let's remove this also. Okay, after that, what we have done, we have current dot next equal to null, so current dot next also became null, and current dot previous also became null, so this link is also gone. So basically we have deleted this node, so yes, it is working properly. Okay, now let's go back. Okay, so now let's see if the index is 0. If the index is 0, we will simply call the remove first node and it will do the work. Okay, now let's try it for some other node, for 5. Just suppose for 5, I think we have already done for 5. Let's take some other example. Just suppose for 3. So what, for 3 we will get a current node for that, so current will be here. Okay, after that, what is going to happen, we have getting the previous node, this statement is executed, then we are going to get the forward node, this is executed. After that, previous dot net is equal to forward, so we'll build a link from here to here, this is done, and this link is gone. Okay, after that, forward dot previous is equal to previous, so this will come to this point, and this link is gone. After that, what happened, current dot next is equal to null, so this link is also gone now, and current dot previous is equal to null, so this link is also gone. So do you see that yes, it is exactly working as we have wanted it. Okay, now let's go on the editor and run our code. Okay, so let's run this. Okay, yes, we have missing return statement, we haven't returned something. Okay, so we were this was, yeah, okay, when we reduce the cells, after that we have to return the node. Exactly, let's go write this. We have to return current from this point. Okay, so this is also done. Now let's run this again. One more error, 190. Missing return statement. Okay, I got it. One more thing, we have forgot to return in this condition when the node was when the index was equals to the size minus 1, and when the index was 0, we have to return the node in this condition also. So for that, we have to do this. Now run this code. Okay, so it is successfully accepted. Now let's submit it for all the test cases. Okay, so all the test cases passed. Now let's talk about the complexity of this solution. Okay, so here we are. First of all, what we have done, we have removed first node. This is for O of n, O of 1, and then we have removed the last node. This is also the work of O of n, O of 1, sorry. And after that, we come inside this else. Inside this else, what is happening, we are calling a function get node add. If you have seen get node at, what happens here, okay, what happens here, there we run a loop. Let me show you. Get node at, this loop runs until we reach that index, and after that it returns the node from that. So it is the function of O of n. Okay, so here what is happening, here we are getting this for O of n. Okay, and then this is also a work of O of 1, this is also a work of O of 1, this is also a work of O of 1, O of 1. Okay, okay, so this is also a work of O of n, O of 1, O of 1, O of 1. Okay, so overall everything is just a work of O of 1 except this get noded, it is the work of O of n. So conclusively we can say that it is a work of O of n. Okay, so I hope you have learned something. Please like and share the video and subscribe the channel. Thank you so much.